Schneider,
Schneider Electric.
Schneider Electric. Okay, all right,
Schneider Electric.
Schneider Electric. I always get criticized for how I say Schneider.
No, there are multiple ways to say it, but it's Schneider Electric.
I gotta have the electric at the end.
Yes.
All right, all right, all right. Well, so
You know why?
why?
Because some people thought that we were an elevator company.
Oh,
Or a TV.
that's Schindler, or there's in the
Yeah.
in the U.S. there is a trucking company called Schneider.
Yeah.
Yeah, it's like they're orange, and I just got to mute.
And in France, even more, we had a company making TVs
Oh, really?
named Schneider. So people knew Schneider as a TV company, and they were keeping asking. So we said Schneider Electric.
Electric. Okay, Schneider Electric. All right, that's a good thing to know. Oh man. All right. Well, I know that you're a busy guy, and I know this was a tough week because we had our plenary here in Lisbon,
Mhm.
and it was rainy, but it was still good. I mean, I know you were shooting for sunny weather, but
Yeah.
everything else went.
We tried to organize plenaries in multiple areas, changing each time. We were in Cleveland, Ohio, last
Yeah.
autumn, and 1 year ago we were in the Netherlands. So we are trying. We were in spring in Tallinn, in Estonia.
Oh yeah. Nice.
We are changing place all the time. So
Excellent.
for January, people are looking for more sun. So I was expecting to have more sun in Portugal.
Yeah, and we weren't expecting to get back in Weird in West Virginia. We got like 18 inches of snow, and that storm just went straight across the Atlantic, right over here. And I saw it as we were flying over. I'm like, okay, we're gonna get the rain, and we did.
Yeah.
We did. But we got umbrellas, so
Yeah.
that was good thinking. Very good thinking. Right. Well, so why don't you want to introduce yourself, who you are,
Okay.
all that jazz.
So I'm Yannick Neyret. I am a Schneider Electric employee. I'm French, working in France in the area where we will have the Winter Olympics in 2030. Okay, in the
Excellent.
mountains.
Are you competing?
No, I'm sorry, I'm not fast enough on the skis.
Okay.
So I've been in Schneider Electric for 37 years
Wow.
now.
Which,
And I would say always in the offer creation and trying to have innovation embedded in all the offers and really focused on innovation for the last 10 years.
mhm.
And I've seen the premises of or the first signs of DC
Yeah.
from 2019. So some have seen it earlier. I've seen it in 2019. So I'm fully committed to the DC topic
Okay.
since that time. Schneider acquired a small company in the Netherlands in 2021. So I was preparing all the work before. And it was at the period where we created currentOS.
Okay. So that's okay. So currentOS was created in around 2021.
Yes.
Awesome. Okay. How is it incorporated? Is it it's an organization, but it's an organization of membership. It's not like an organization where you have employees and you have
Absolutely.
okay.
So there is a name for this in the American language. It's Standard Setting Initiative.
Okay.
But from a legal perspective, it's a non-profit registered in Amsterdam.
Oh, okay.
And we have partners.
Good.
These partners are companies, and we have today more than 120 companies that have joined. Very small one, medium size, and very big ones.
Mhm.
The small one bring agility, speed,
Yeah.
and the big one brings the power.
Mm-hmm.
So it's a really great combination.
Absolutely. And I like the way you put that because larger organizations move slower, I would say.
Mhm.
The small organizations are more agile, they're more
Exactly.
risk takers too,
Yes, sure.
right? They're the early adopters and innovators.
Mhm.
And then you want to fuel them with
Mhm.
the technology. I
Absolutely.
like that. That's a
And
explain.
DC for all the electrical companies, it's a bit of a Kodak moment.
Oh,
What should we do?
yeah.
Continue to invest in what is making our profit today with AC, or derive some money for this new emerging technology, which
Yeah.
is still a risk, still a bit uncertain at the moment, but some people, like I am, are really thinking this will be the future. I don't think it will substitute all the AC business,
Right.
but it will be a big part of the electrical business.
Yeah, yeah. Okay, so you're so Schneider Electric. What do you do at Schneider? What's your role?
I was innovation director,
Innovation
so,
director.
leading some innovation projects.
Okay, okay. And then we create currentOS,
Yes.
and now you have a role in currentOS. What's your
So
role?
I've been creating currentOS at the very beginning,
Hmm.
starting at the time only two companies, Eaton and Schneider Electric together.
Hmm. Yeah.
And I've been the president of currentOS since that time.
Since that time.
Yeah.
Excellent. Okay. And now we just changed some bylaws. So I heard you say
Yes, yes.
in the meeting, you're like, okay, now you are chairman of the
Executive committee.
executive committee.
Let's say it's a bit of a technical topic just to
Yeah,
say adapt to the legal constraints, but
that's right.
I'm still leading the operation in currentOS, even if the name has slightly
Yeah,
changed.
absolutely. But the great thing is that as an organization, we're adapting and modifying and growing.
Mhm.
I mean, we're over two, what was it, 200 and how many members now?
120 companies.
120 organization companies are members, and that was from two in
Yes,
2021.
yes, exactly.
That's a phenomenal growth
Yes,
perspective.
yes, absolutely.
Yeah.
And we have both, as I'm mentioning, very small, but also big names. Okay.
Oh yeah.
So big names known in the electrical distribution, like Eaton, ABB, Schneider Electric,
Mhm.
Siemens, but also in the cable industry, Nexans, NKT, Prysmian,
Yeah.
Fire. Also in the heat pump companies like Daikin, Train, Hisense.
Yeah.
So we have a lot of big companies bringing a lot of legitimacy to this organization.
Yeah.
I just mentioned three sectors, but there are also others in the engineering, in the installation, etc.
Yeah, and maintenance and educators too. We had some.
Absolutely.
Yeah, so and that's a really good because I was speaking with Antonello a few minutes ago, and we talked about one of the biggest one of our important things that we need to do is educate people,
Mhm.
right? And the
Absolutely.
more people that we get educated on some of the fundamentals, then when we lay our system design architecture over top of that fundamentals, inspectors will know what they're looking at when they're inspecting it. The installers will understand what they're doing and why they're doing it.
Exactly.
And then the designers will figure out they'll be using our reference documents to lay out a system that is safe and well, it's all in design, but it's the fundamentals. If you're
Sure.
following the rules,
Sure.
addresses the risk involved with these
Absolutely.
power systems.
In currentOS, I would say we have four drivers. Um, the first one is we need to overcome the DC perception of unsafe.
Yeah.
Okay. Electricians are most of the time scared about DC.
Hmm.
So we need to deliver a solution that is super safe, safer than AC if possible, so that we have the possibility to, I would say, to convince and to make them comfortable with DC.
Sure.
So that's one thing. The second driver is we need to make a multi-company system, a multi-vendor system, for two reasons. We well, as Schneider Electric, for instance, we are not making elevators, we are
Mhm.
not making heat pumps, we are not making lighting systems.
That's right.
So we need other companies to bring this system together. So we need a multi-vendor solution. That's absolutely important. The third driver of currentOS is then we will have to have contractors or engineering consultants to feel comfortable with this, to feel empowered or yeah, comfortable to design and to implement or to integrate this kind of system.
Right, right.
We need to make this simple for these guys. So uh, safety concern, get rid of that. Multi-vendor, so that we can have the full scope of supply for a big building, for instance.
Hmm.
And then for the people who will make it happen, make it simple.
Right.
Okay, microgrid in AC are not that simple. You need to have an electrical system. You need to have an automation system. You need to combine both. You need to evolve both at the same speed.
Yeah.
in with DC, we have an opportunity to make microgrid multi-sources system much simpler,
Yeah,
but we need to specify in a way that it is simpler.
that's
Okay.
right. Do you think it'll ever get to be what we call plug and play?
I hope so.
Yeah.
I hope so. Wow, there will always be some commission.
Always,
We are
yeah.
trying to make it super simple, and I can illustrate thanks to um, our semiconductor protections.
Hmm.
We can reach a design where the protection are so fast that selectivity calculation is not needed anymore.
Mm.
Because always the breaker the nearest to the fault will see
Okay.
the fault. The just the inductance of the cable will be enough so that the current does not come from anywhere else from down the nearest capacitors.
Right.
And then
Right.
selectivity is so this is an
Inherent.
example. Yes, this is an example of how we can simplify the life of people that have to design a DC system.
Right. Yeah. Yeah. So so, and that's what Antonella was saying is that because of the architecture is going to be different,
Mhm.
and our the documents that we're working on with regard to as part of current OS will help the designers lay the system out so that they achieve the
Yes.
goals and it's inherent in the system.
Absolutely, absolutely.
I like
Yeah.
that.
And the fact is, we also need to, well, back to the education point, we need to educate because um, what we are doing in AC sometimes do not apply to DC.
Yeah.
Um, an AC installation is a very inductive system. Starting from the transformer or the generator set, you have inductive sources. Then everything is inductive in an AC system. In DC, it's exactly the contrary. You have capacitors everywhere.
Yeah.
So this makes things uh, pretty. You need to think differently.
Yeah.
What you are doing with voltage, you need to do with current in DC, and what with you are doing with current, you need to do with voltage,
That's
etc.
that you know what, and that helps me understand because I when we were talking about selective coordination and when I first started getting involved, I would raise my hand and say selectivity. There's intentional delays, and then the Antonellas of the world would go, no, we don't want delays,
Yeah,
because
exactly.
the capacitance and the voltage, and so you have to be fast regardless, and we can get that speed. And you're right. My mindset, it's like speaking two languages, which you do. You have to, your mind has to change when you're in
Absolutely.
English, and then your mind has to change when you're in French,
Yeah,
right?
exactly.
So it's the same thing when you're dealing with DC, and that's why I think it's really important that organizations like NECA, IBW, independent electrical contractors, and others, and there are, like I learned this week, there are similar organizations in Europe and in Asia
Absolutely.
Pacific, et cetera.
Absolutely.
So they all have to get engaged.
Yes.
And the sooner they get engaged, the better off we'll be because you don't want to have to try to learn the system all in one motion. You got to
Absolutely.
get the fundamentals down and then ramp up to
Absolutely.
the technology. So
Absolutely. But if I may add something,
yeah.
there is a fourth driver I did not mention.
Ah,
The fourth one is why are we doing this?
oh yeah. And why now? Right?
Well, let's start with why.
Okay. All right.
Well, there is a stupid thing that could say, okay, every device around us are DC native.
Mm.
Okay, uh, LEDs are AC, batteries in your laptop are
Oh
DC,
yeah,
all the
absolutely.
electronics are DC. Okay,
Yeah.
that's one thing. Even home appliances are DC because you have a motor, but to be efficient, you have a speed drive. So there is DC somewhere. Okay.
Mhm.
So that's, I would say, a first step, but it's not enough. It really is a game changer if you bring something really new, not just a few percent of efficiency. Okay. And this is where DC can bring something totally new because we have the capability with all these converters in the system to manage the power. So today, with AC system, we manage the energy. So meaning that we can stop some loads, we can start some loads, etc. So in the end, the kilowatt hours, your electricity bills
Yeah.
is controlled, under control. But with DC, we can not only do this, but also control the power, meaning the peaks. You know, all the
Oh
what
yes.
we hear in January that there will be peak power, and the
Yeah.
utility will struggle to provide all the power needed at 7 p.m.
Yeah.
In households, etc. With DC, we have a capability to really control this power,
Hmm.
and doing this with some buffers like batteries, like thermal buffers, and so on, really make the building having a much lower power demand
Right.
on the public grid. And then in this, bringing something totally new. If and when I say lower, divide by 3 to 5.
Mhm.
So a building that would require 1 megawatt would just require 200, 250 kilowatt tomorrow. And maybe for the 1 megawatt building, you need a new line, you need a new transformer.
Yeah.
And with 250, you could have the spare capacity, and you don't
Yeah.
need an extension of
For the entire grid.
again.
Yeah, the entire grid gets that back
Yeah.
just because you're doing things more. So how is it that I can be more efficient with DC? Is it because of losses? What gives me that energy?
Obviously, the in terms of energy,
Hmm.
obviously you will have some gain in energy in the converters. Okay, but
Sure.
I was speaking not about energy but about power, and I would say maybe we can take a little bit differently. DC is not so much moving from AC to DC, but it's moving from electromechanical to power electronics in electrical distribution. And this power electronics that is inherent to DC and required with all these capacitors, etc., provide you the capability to have much higher control. And it's not on off like a contactor is doing in
Right.
AC. It's
Right.
really, well, for electricians, maybe this image do not speak to everyone, but imagine you have a variable speed drive on every load. You have a variable speed drive in your dishwasher. And when you
Right.
push the economy program, it's not anymore just optimizing on the cycle in kilowatt hours, but optimizing upon the sun on your roof and accelerating when there is sun and slowing down.
When there's
So
not.
when you press this echo button, you may not know how long it will take, but you are sure that it will make the most of your
Okay.
local resources.
Okay. So every device is smart, so to
Yes,
speak.
exactly.
And so now I can manage my entire distribution system, whether it be light fixtures, appliances, or whatever it is. Now everything is communicating, not necessarily communicating, but aware and
Everywhere.
and pulling power and managing its usage in a system.
Exactly. And this topic, this word of communicating is interesting. If you want to do this with an AC system, you need communication.
Oh
You need
yeah,
a brain that control everyone and say, you start, you stop.
right.
With DC, we have a very simple mechanism. We just make voltage fluctuating.
Yeah,
And as every converter has everything to measure the voltage, it's a signal for everyone. Voltage high, happy hour, we consume, we charge the battery,
yeah,
we charge the car.
yeah.
Low voltage, when we speak about a few tens of volts, it's
Right.
small fluctuation, but this small fluctuation indicate everyone, wow, it's low. So we need to discharge a battery, we need to slow down the dishwasher, we need to stop to make hot water, etc.
Wow. Okay, and that's a valid point. Like even with lighting controls and things like that, I need a communications.
Yeah.
I'm either going to turn something off, and for me to turn it off, I need communication to be able to do that. But in a system, a DC system, you're running it off of, and it's making its own mind up.
You still need a button on communication
Sure,
to have the
to
light.
turn it on or off. Yes,
But I would say to make your dishwasher follow your PV production,
sure.
this is totally inherent,
Yeah,
totally native.
yeah.
When with this droop control, technical people speak about droop control. This is really something that where DC is a game changer.
Good. Okay, I get that. I get that. It's coming together for me.
Mm.
It's coming together. So we understand it's not just about all of the bricks that we have. I call them bricks
Mhm.
to get from AC to DC. It's not just about that. It's about managing the entire distribution system
Exactly.
and the flow of energy.
Yes.
Why is there a, I want to get to why now.
No.
I'm not sure how to get that. Like why didn't we do this 100 years ago versus is now the right what stars aligned?
Yeah. So I would say, why didn't we do 100 years ago?
Yeah.
Answer is very simple. Uh, at the end of the 19th century, you did not have electronics. So,
You-
so you had only electromagnetic system, coils, and iron to make transformers. So AC was an obvious solution. Okay. Then why now, with a more recent scale? I would say I don't know why it did not happen in the 90s or in the early 2000s. Okay,
right.
probably because we have a few crazy guys that were, I would say, in opposition to all the AC guys that just made some pilots,
Right.
and it start to prove what they were thinking. These crazy guys are considered as crazy guys.
Hmm.
They just proved. And in the Netherlands, in 2017, there was a building named the Circle Building that was created. It was a restaurant with meeting rooms and so on.
Hmm.
That was implementing a full DC distribution. It was a few crazy guys that made this
Yeah.
sustainable building, not only on the electrical side. It was all reused, old clothes to make the isolation,
Yeah.
old windows to make internal doors, etc. So it was really a full concept. But 9 years ago, we had a building open to the public where people could visit.
Hmm.
Well, the first reaction was, well, nothing changed.
Right. Yeah. You wouldn't expect to change. Yeah.
For a visitor, nothing changed. But from an electrical management perspective, it was a total change because the power connection to the public grid that is really, really under constraint in the Netherlands was much, much reduced. So, well, we had these pilots. There are several pilots in China. They are all several of them popping up here and there,
Yeah.
start to make people think, wow, these crazy guys are not so wrong.
Yeah. Yeah. There's something to this.
Yes.
Yeah. And what drove that though, probably what when I think of just from like in the United States, we don't have as much exposure to brownouts and things like
Mhm.
that. But I think in other areas of the globe may have more of a challenge in that regard. Because I'm trying to think of what would drive somebody in what part of the globe to say this is a problem I have
Mm.
and this could be a solution,
Mhm.
right? Because usually
Sure.
we're all engineers and
Sure.
that's what we do. We solve
Sure,
problems.
sure, sure.
So
Absolutely.
it could be that in the Netherlands, could it be in the Netherlands, there's a power consumption versus generation imbalance?
In fact, again, it's not an energy question. So there is enough power generation.
Hmm.
The problem is about power, and the problem is more about the distribution system. And the Netherlands is very interesting because it's a very it's a very rich country,
Hmm.
okay, with a highly dense population, more than 3 inhabitants per square kilometer. So it's really dense.
Yeah.
It's like a big, big city, okay.
Okay.
And people are struggling to have land for the delivery substation. People are struggling to implement new lines because they need to open the streets when they want to reinforce the grid.
Yes.
And then they start to have all of this um, move to electrical vehicle. It's the
Yeah.
first country in the European community where in the European Union with electrical vehicle. We had also due to the Brexit some data centers that moved. So the financial market moved from the UK, part of it from UK to the Netherlands. So a lot of data centers were creating here.
Ah,
So we had in the last 15 years a big increase in the power demand. So very dense area,
yeah.
difficult to expand the grid for land reason.
Yeah.
A lot of shift to electricity for vehicle, for data centers. I didn't mention, but they had gas resources there, and when they ran out of gas, they started to incentive the people to heat their houses with heat pumps or with electrical cooking, for instance.
Oh yeah,
So
yeah,
all
yeah,
this made a big transition to electrify the usage and
yeah.
the life of the population, and it revealed this problem of power demand.
Mm-hmm.
And they have enough energy, kilowatt hours, but the problem is the peaks
Mm-hmm.
in the evening when everybody comes home,
Home and yeah,
go on Netflix, connect the car to charge.
that's right. Yeah.
So,
Yeah.
so, and I think Netherlands is a very good example because we are not speaking about a very poor country where
No.
there is no grid, etc.
Right.
It's a mature economy with a mature public grid,
Yeah.
with something that can be replicated in most, at least big cities
Yeah,
in the
most
world.
large cities. Yeah, I mean, you look at if I look at even in the U.S., you got New York
Exactly.
and all these cities are growing. And to your point, to say I'm going to put a substation in downtown New York, I'm going to take real estate
Yeah.
and I might have to say, well, that building's got to go, and that's a lot of money. So if you could do things smarter,
Yeah.
and now I can live with the same footprint from a occupancy perspective
Mhm.
and deliver more power over the existing infrastructure.
Or deliver the same power, but power more buildings
That's
with
right.
the same power.
Yes, and you're just managing. So you're alleviating off of the grid by managing the usage by making all the devices smarter
Exactly.
and you're controlling them via voltage.
Absolutely. So there is one thing I did not say in the circle building. One of the goal was achieved also because there is thermal storage. So the fact is, you have let's say an air conditioning system that blow cold air or hot air depending on the season
Mhm.
only when there is a lot of power available.
Yeah.
Blowing this on a storage system that is phase change salt.
Right.
Okay, so whatever the temperature you blow on this salt, on the output of the system, you have always 23 degrees. So
Mhm.
it's constant. So
Right.
when there is no power, you just stop to inject energy into this system, and the output temperature is always the same.
Same.
So the occupants don't see any effect on their comfort,
Right.
but you can manage the fluctuation of the power.
Yeah. But now the structure itself has to be built to maintain that temperature. So
Yes.
the insulation and
Yeah.
all of that makes a big difference.
Sure.
In some areas of the way, I know just even like the house I grew up had no insulation. It was
Mhm.
built in the whatever the teens, right? So
Mhm.
early 1900s. And we had knob and tube wiring. We didn't have any insulation. If you turn the furnace off,
Sure.
it's getting cold quick.
Sure.
So, but that's now structurally across the country or globally, buildings are constructed differently.
Yes. And I would say energy price is rising. So
Yeah,
whatever the energy we use, we need to do things to consume less energy.
that's right.
But if and one way is to have heat pump because you take one part of energy from electricity, but a big part from the air
Mhm.
temperature. Okay. So this help to, but and then we can control better the electrical use of this new
I
system.
like it. I like it. So the reason why now is because technology and I would if I would when I think about metering,
Mhm.
I when I started at Eaton, I was on the help desk and I supported our metering products and solutions. And I can remember even when I was in consulting, when I was doing power systems analysis, I would run across relays and whatnot. And if you look at history with regard to that technology, it was we started to do more in smaller devices
Mhm.
because of the integrated circuits and
Mhm.
microprocessor based solutions. We didn't have that before. A computer was a room.
Sure.
Well, all of a sudden, computers got smaller. We said, hey, we can put relays and we can do ground fault protection and all these other technologies. And now we're like, hey, now we got these other we got power electronics now,
Mhm.
and that's even smaller and more efficient. So now you're migrating, and probably when we're both sitting in a rocking chair on our front porch, drinking some scotch or some wine. Somebody else is designing systems that are based upon what's occurring at meetings like this by innovators like Antonello and others, right?
Yeah, absolutely.
So we're breaking new ground, so to speak, and
Sure.
and it's because technology's gotten where it's at.
Absolutely.
I like it. I like it a lot. So that covers the why now.
Mhm.
So now from an organization, so currentOS 2021, you're still leading the charge. What's what's like what are some of the goals for the organization? I mean,
Okay. So, if we want, well, we are a non-profit and we are on a standard setting initiative. So we are not here for business. We are
right,
here to support company to make business, but we are not making business ourselves. Okay. So what can we do? One thing we can do is to design a system derived from this product specification, because a lot of companies are, well, let's take an example. A heat pump company is an expert in fluids, compressors,
right,
efficiency, but maybe not an expert in electrical distribution. So we will provide this kind of companies some specification how to make product to be compatible in DC. So that's one thing. Second thing is, if a contractor somewhere want to use a DC heat pump,
hmm,
if he get one that is certified compatible with one system like currentOS system, he will feel much more comfortable to use it, because he will know that there have been some third party assessing that it will work.
right,
So the second thing we can deliver to help the business is a certification scheme to prove that these devices are compatible. So, and this certification scheme will be in place in 2026. So we will start from 2026 to have devices in DC with, I would say, a mark saying that
yeah,
they can work together
yeah,
without the pain to check in the data sheet what are the voltage, is it compatible with this other system,
right.
etc. This is done.
Yeah, and I know so that is a very important piece of our work and why you have Schneider Electric, ABB, Siemens, Eaton, and Train, and all of these other different people working together because you want to be able to say, I can have like today in the AC system, I can have a Train air conditioner, I can have a Schneider Electric switchboard, I can have an Eaton switchboard, Eaton panel boards, Siemens panel boards, and they all work together because
Absolutely.
we know it's 480-volt equipment or 600-volt equipment in Canada, and we over here it's different voltages, right? But it frequencies 60 hertz versus 50 hertz, but you sort of know the rules of the road, and we have standardization. So I can buy circuit breakers. I may not be able to put an Eaton breaker in a Schneider Electric panel board and vice versa, but I know I can buy product
Mm,
and develop my power distribution system.
exactly.
And you're going to look for the current OS logo to say, look, we've already done the work for you.
Yes.
We know all of this is going to work together.
Yes.
Yeah,
Absolutely.
I like that. I
And
like that.
we need also this certification part, because in standards, you mainly cover safety aspects.
Yes.
But as I was mentioning, there is, when we go to a microgrid and power management, there is a control topic. And this interoperability aspect are not and will not be covered by standards. So this certification will prove that not only you have the right safety between an Eaton or a Schneider Electric circuit breaker and a train heat pump in DC, but also there is interoperability for the power management as well.
That's right. So that's that droop. That's that when the voltage goes down, they
Yeah,
all behave a certain way.
we prove that it's
Yeah.
implemented properly.
Yes, and that's Antonello's challenge from a technical perspective
Yes.
to develop those standards so that when the voltage gets to a certain level, here's how everything behaves.
Exactly.
You're going to go into a management mode. You're going to maybe shut off. You're going to start
Exactly.
drawing power.
Yes.
You're going to push power from the battery. And then when the voltage comes back up again, all right, now the battery, we're going to start storing energy over there.
Exactly.
And now, what did you call it? It's feast. It's party time, right? It's party time.
Yeah,
The
yeah.
power is
Happy hour.
It's happy hour. That's the term. I love that. It's happy hour.
Yeah.
Perfect.
And well, just to also clarify one thing, these group control are software defined.
Yeah.
Okay, so the system will not impose to run your dishwasher while you would like to have your car charged, or the contrary.
You
Okay,
prioritize?
you
Yeah.
can make the changes. Okay, you can
Yeah,
do
yeah,
what
yeah.
you want, but
Yeah.
you have a kind of incentive that
Sure.
from the voltage that tell you, well, it's not the right moment to do this.
Right.
Otherwise, you will pay a lot of electricity from the public grid, or it's the right moment to do this because now it's free. It's happy hour.
Yeah, yeah. And so, like, to your point, it's not going to be like you are, because I know a lot of people don't like, I don't like when you tell me what to do.
Exactly.
Right? So I want to make my decisions. And if I want that power save mode,
Mhm.
I turn the power save mode on. If
Exactly.
I don't want that power save mode on because I'm doing something and and I don't care, I know I'm going to get a little bit bigger of a bill because I'm going to use energy. I can still make that decision. It's not that everything automatically
Hmm.
is going to happen for me. So
Absolutely.
that's a valid point. I don't think
Yeah.
we've
And
brought that up.
power demand solutions we see on the AC side, and pushed by some utilities today, are pretty intrusive.
Yeah.
You get something that will shut down your boiler. As long as it is only your boiler, it's not a problem. But when it comes to your car charging,
Oh yeah.
you
No.
need your car to be charged, and the utility bring a signal that shut it down. But
Mm,
that's become a problem. With this DC approach, you master your priorities. You know what will be the cost,
I like
but
that.
you can choose.
Yeah, no, I like that. I like that better than, because I know in some states in the US, they'll have it on the, I think it's on the HVAC or the hot water tank.
Mm,
They'll shut your hot water
yes,
tank off,
exactly.
and you may say, well, I was just going to take a shower.
Mhm.
Right now, I can't take a shower. So, and that's important. So, but if this system is managing it for you, and you don't have that somebody else
Yes,
saying, "Hey,
exactly.
I'm going to turn this off," because
Yeah.
you're managing your loads.
And
I like that.
and you're doing this, I would say, with a low digital control. So you keep this
Yeah,
as your it's private.
yeah.
You don't expose to the world that you charge your car at this moment, or you need your dishwasher to run at this moment.
Oh man,
It's your problem.
that is it's your problem. I like that. I like that. Yeah, yeah, because that's always another concern,
Mm,
right? It's what am I sharing? What information do people have
exactly.
about me? And I don't want
Exactly.
people to have that.
Exactly.
Yeah, no,
And
I'm getting it.
and in addition, having digital on the power system for me, well, you want power. Okay,
Yeah,
you need more power than information, even more. It's
yeah.
a Maslow pyramid. It's really at the bottom. So the least you interface the system, the more this one is autonomous, the
Mhm.
more chances you have to have this power available.
I like that. I like that. Yeah. No, I'm getting it. I'm getting it. So I get how it operates. I get how it controls. I get why we're here today, and why we didn't get here before. And so current OS is going to continue to provide the opportunity for manufacturers and installers and others to understand this system
Exactly.
and get it to function efficiently.
Absolutely.
Okay, I get it. I get it. So
And to your point of what are the objectives, there is
yeah,
another one I did not approach. We need also to help investors, architects, people that are not electrical specialists to understand the benefits of what we do. So we are spending a lot of time also with journalists, with social media to explain,
yeah,
raise awareness about the possible benefit of this new technology
that's right.
without speaking to technical savvies, but just really
Yeah.
to raise awareness.
I like the conversation we had in the plenary session. I think it was yesterday. Today's the last day, right? Yeah,
Mm,
yesterday. Somebody made the statement, "How do I tell grandma
Mhm.
of the benefits of DC,
Exactly.
right? And that's our challenge is, we love to be technical in nature
Mhm.
and we migrate there. And I know I get accused of this, and even when I do educational programs, they'll say, you were way over here and you need to tone it down and bring it down to earth. That can be very hard for a physicist like
Mm.
Antonello and electrical engineers and others who live in the world of all those details to try to simplify things to say, okay, there is a value.
Mm.
And I love I love that message that conversation we just had with regard to the control of the system where I'm using less power and I'm getting the same amount of work done.
Mhm.
I think that I think and but to your point earlier, you walk in and I got lights. I'm going to
Exactly.
turn them on and off. I
Exactly.
don't see any difference.
Yeah,
But you see the difference in the check that you have to write every month for your utility bill.
absolutely. And if I don't speak to the grandma, but maybe to an investor
Yeah,
who is not an electrical specialist, we could also say, look, you have a project, you want to create a building there, and maybe the utility comes to tell you, I'm sorry, I have no power for you. What do you do? Do you delay your investment? You have the land, you delay your investment by 5 years, 10 years? Or do
right.
you find another solution? And in many areas, densely populated areas, this is now a question.
Yeah, and the other aspect of it, even if let's say that energy, I'm not going to have a utility tell me I can't give you power. Let's just say that that's the case. I'm going to build a structure
Mhm,
and I want I want you to come and buy a flat,
mhm,
right?
mhm,
And I want you to live here.
mhm,
And I know you have a lot of other choices.
mhm.
And in my advertisement, I say, look, your energy bill is going to be here. We've implemented the latest in technology, and I don't even have to say that it's DC distribution because most homeowners don't care if it's DC or AC. The
Absolutely.
lights are on and everything is
Yeah.
functioning. So I can say that I've implemented a system where your energy bills are going to be less. I could, because of the reduced in wire, I mean, we talked about that, right? The reduced in cost of the infrastructure.
Absolutely.
I might be able to make the rooms bigger. I may be able to get more square footage
Yeah,
out of my structure,
absolutely.
right? And now that is a huge value proposition.
Mm,
Forget about the technology and but we're putting the technology in, but forget about all that and say, look, you're going to be able to have more square footage. You're going to be of value to your potential buyers
mhm.
to say, I'm going to have lower energy costs. That's a good
Absolutely.
value proposition.
And in case of power outage, even if it is a short one,
Yeah,
you will continue. You will not even notice that the grid around you
it's gone away.
has gone away, and when it comes back, you don't even notice either.
Yeah. Yeah, you might do this and go, my watch just told me I had an outage about 3 hours ago.
Oh yeah, yeah, yeah.
Yeah.
Okay.
Oh, wow, yeah,
Uh,
my neighbor's without power right
yeah,
now.
yeah,
Look, I got everything.
yeah. No, you don't have everything, but you have what you need. You have
Yeah,
your
yeah,
priority. You have your light. You
yeah,
have your electrical devices, and probably you will live on your stored heat to
yeah.
keep the comfort or stored cold. You will live on the battery of your car, but for a few hours, what's the problem?
No, that's exactly right, and what do we do now? We have to buy generators.
Mm,
We have to put generators outside. We've gotta build an infrastructure of a transfer switch
mhm.
and all of that, where now the system inherently gives you that because you've got energy
Exactly.
storage, you've got the system, the smart devices that are, "Hey, I'm in this mode, I'm in that mode,
Mhm.
I'm going to adjust," and you've prioritized what you want focused on.
Absolutely.
I get it. I think there's a value, like you said, to investors or to people who build structures. Because I know when I got involved with LEED, right,
Mhm,
building building sustainable buildings and having that label, whether you are platinum or gold,
mhm.
that was very much so a marketing effort of I know Eaton's building, Schneider Electric's buildings. We all have those plaques on there because it shows you're a sustainable organization.
Mhm,
It's at your core.
mhm.
And when you have that, if you had a structure and say this is a LEED gold building, that appeals to a lot of people,
Absolutely.
and you can command premiums for
Mhm.
that in some markets. So the lead label was and still is a great example of marketing and a structure that's now good for the environment.
Mhm.
A current OS label could be the same, but
Absolutely.
but a homeowner's not going to see that current OS label. But do you ever think that we could ever have a current OS label for a structure? I know that's I mean, we're talking products,
Yeah.
but you know what? I mean, could you imagine if we had a structure that was built with a current OS system and you could give it a gold, silver, okay, I got that on your
Yeah,
golden jack.
could be. But if I'm not wrong, in the leads approach, you get extra points. You
Yeah.
get a bonus when you have a DC installation.
Oh, that's yeah, we contribute to
So
points.
yeah,
That's right. Yeah,
I think
there is a
so.
lead aspect of it.
So it starts already. It's already
It's
implemented.
already oh man, I gave you a goal and you said it's already done.
Yeah, yeah. I love that. I love this kind of goals.
Yeah, done. The next one, Tom. I love it.
Yeah,
It's a
yeah,
good one.
yeah.
But no, yeah, you're right. So yeah, I forgot about that. You can get credit
Mhm.
because it's recognized as a sustainable solution.
Mhm.
And that would be a great thing even for current OS to try to even get specific recognition and lead. You
Sure,
know, that would be another really great a
sure.
really great thing to play with. I got to think about that myself too, because that would be. I mean, the more because you're right because you have the value to the designer. You
Mhm.
can make life simple with
Mhm.
interchangeability and all the things that we're doing. You have the value to the electrical contractor and the electrician from a safety
Mhm.
perspective,
Mhm.
right? And then our standards have value to the inspectors so that it's easy
Yeah.
to give that,
Mhm.
occupancy sticker, but also to the developers and the architect
Sure.
to say, look,
Absolutely.
this is a viable solution you need to consider because it will provide value to your structure. You're managing the footprint.
Mhm.
Your occupants will have lower energy
Mhm.
bills,
Mhm.
have more control
Absolutely.
over the entire every aspect of their power distribution system. And they would have, I mean, if I was renting like this structure here, this is a school, but if this was like an apartment building and this was my facility, I could implement
Mhm.
all of the common areas and all of the areas that would be a heavy energy users. If
Mhm.
for centralized, I could be managing the footprint of that
Absolutely.
myself as the owner of the structure, and then that saves me money at the end of the day. There's value. It's like let's throw in a little bit of DC. Let's throw in a little capacitors and let's sprinkle on
Mhm.
some extra funds for the owners who build these structures. There's a lot of value to go around.
Yeah.
There's a lot of reasons why to go this route
Absolutely.
outside of anything else.
And back to currentOS, currentOS is not pushing for one solution. CurrentOS is mainly, I would say, sometimes a think tank,
Hmm.
where people join their forces.
Sure.
And we were speaking about leads. What could we do with leads? Okay. Well, personally, I don't know. I have no clue, but probably there are other partners or potential partners that have
Yeah,
contacts. So bringing our forces together, and
that's right.
it's really the core of currentOS is where people think together about how to grow this, uh, facilitate this, help this. We are
Right.
not speaking about prices, not about project,
No,
but
that's right.
how we could help this new game changer technology
Yeah,
to become live, to become, I would say, something that is really available
yeah,
for the mass market.
yeah. You give the opportunity
Exactly.
for those discussions to occur and grow the efficiencies to bring value to all of those different players. I like that.
Absolutely.
I like that. It's I like it. We got through a lot of this. Barriers? What about barriers? I mean, we talked about a little bit about the perception, and we're developing the standards. So I hate to say codes and standards is a barrier to success. It's a necessity,
Well,
but
it's a barrier not to have. You know, the contractors, they need to feel comfortable.
Yeah.
Every house is different. Every building is different. They need speed. They need to be fast.
Yeah.
So they need to have a straightforward way. So having code and standard properly defined for DC give them confidence. So
Mhm.
the barrier is not to have is when there are gaps in the standard.
Yeah.
And today, this is the main problem to take off with DC business at a big scale, is that our contractors, our panel builders, our electricians do not feel yet comfortable with DC just
Right.
because they don't know.
Yeah. 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 That's right. Yeah.
And standard is a way to bring them confidence, but it's
Mhm.
not the only one. We also need to bring knowledge to the professionals.
Yeah. And I think that's probably even a larger barrier is just the awareness and knowledge
Mhm.
because we're so used to dealing AC, even in the standardization world. We just like I go back to those meetings at Code Panel 10 where we said we're going to put ground fault protection of equipment for DC systems 1,000 amps and above, and I was like, why?
Mhm.
There wasn't like, well, here's the problems that we're experiencing. It was, well, that's what we're doing in AC, so we'll do it in DC, and that's not the right answer because it's a different system. And
And
it's a
even
knowledge thing.
if the guy was willing to go, willing to try, in the quote, he would put some margin, some buffers,
Yeah.
and and
Oh, yeah, absolutely.
and this would increase the price. So if we want to have these buffers to be removed, we need to bring confidence.
Yeah, you're right, because when there's the unknown, you say, "Well, I don't know what I'm gonna miss in my quote when I'm designing this power distribution system." So you add those adders in just to so you don't lose money on the project from a if I was a contractor or whatnot. But the more confidence you give them and the more awareness, then they can streamline. Exactly.
Exactly.
They know
Exactly.
this is how we put it together, and that's one of our goals.
Yeah. But and if I can complement on this, today we know already that for street lighting,
Yeah.
we even with very I would say low volume production on all these devices, we are already below the AC system. Okay,
Mhm.
street lighting in DC it's already efficient. When you go to EV charging infrastructure, we are a little bit below,
Yeah.
close to AC, a little bit below, with very good value proposition because your EV charging infrastructure can have a connection to the grid that is smaller than the total power installed.
Right.
This is not feasible in AC or very difficult to do in AC. You can guarantee the utility that you will not exceed, let's say, 50 kilowatts because
Wow.
of the
Yeah.
converter and have a 120 kilowatt installation behind.
Yes.
So for EV charging, and I know that in a lot of places it's difficult to implement an EV charging infrastructure just because the distribution grid is
You're
not
right.
enough. So having this capability, so after I would say the street lighting that is so obvious, the EV charging infrastructure is the next one. And then we also start to have a very good conversation with people in charge of data centers
Mhm.
because here the energy saving benefits is so huge that the
Right.
business case is very quick and progressively we will go to more and more use cases. We have very good, as I was mentioning, the circle building, but it's not the only one. We have very good pilots on commercial buildings.
Yeah.
In the near future it will become something we can offer as an alternative to classical system.
Yeah. No, that is a very that's a very good point. That is a very good point. So demonstrating it and implementing it and that whole aspect. So if I think about the National Electrical Code and UL standards recently have been focusing on we recognize that we're using energy management systems for a different function.
Mhm.
And historically, energy management systems have been to avoid a peak demand or understand what you're billing, what your energy usage was, right? So you know how much how much energy it takes to make a phone, and then you could a company can figure out, okay, it takes too much energy to build this, but if I change my production, now I'm spending less in electricity, and you can motivate people that way. But now we were starting to use that same system to size equipment,
Mhm.
right?
Mhm.
To say, I'm going to guarantee that you're only going to see this much load to your earlier
Mhm.
point. And then we created what we call a power control system.
Yeah.
And the power control system has to turn loads on and off via communications or direct hardwires to say this has to turn off, that has to turn off because I need to keep my load down. And then we're trying to manage the sources. So we're trying to do that today in the AC systems,
Mhm.
primarily because of the electric vehicle market, right?
Yeah.
Because the electric vehicles, it's a huge consumer of electricity, and we realize that you can't charge every single car. So I'm going to give you a little bit, and then I'm going to give you a little bit, but you're not going to get any. And then I'm going to manage that
Yeah.
via a power control system where in this type of a world of DC distribution, it's inherently built into the system.
Exactly. Exactly.
Makes life so much simpler.
Sure.
And I get that. Now the challenge is, to your point, is to say, is to flip that. Say you're so used to this. For decades we've been doing this. And now we want you to turn on your French brain or your Spanish brain and whatever. This is a whole nother language. It's a whole nother world.
Absolutely.
And you need to switch. You ever see them commingling? Like I always said, like in a commercial building or a dwelling unit, I could get away with DC lights, but I might not get away from all those AC receptacles.
Mhm.
Do you ever think that we'll get, maybe even as a transition point, to where you have both the conventional AC system for some loads and a DC distribution system?
Probably yes, especially on building. Well, it happened already with a building existing where
Yeah.
you have a parking lot you want to electrify. You can have a DC installation on the
Right.
parking lot and keep the building in DC. But back sorry, the building in AC. But
AC.
back to your point, when you enter a room, what are you looking for? You are not looking for a socket plug. You are looking for a USB plug.
Anymore, yeah. So yeah. So here's my thoughts on that. Here's my thoughts on that. I agree with you 100% that whether it's a computer and even lights. And I made this statement before about kitchens, and I said you're not going to see USB appliances. And lo and behold, my wife buys a mixer,
Mhm.
and we get this mixer in, and we're in the kitchen. I'm talking, and I'm cutting the box, and I take it out, and I've got this mixer, and there's no cord.
Mm.
And then I'm like, well, where's the cord? So I'm digging in there, and then I pull out a little USB thing.
Sure.
And I look at it, and it had a built-in battery, and it had a USB cord, and I was like, I literally that same day at work, I was talking to somebody about, you're not going to see kitchen appliances
Mhm.
that are USB connected. And sure enough, there was one. So I agree USB is critical. But when I think about changing all of those receptacles into USB, I think the technology has to get to a point where it's not a big pill to swallow, especially like in a dwelling unit where things are so
Well,
cost
yes.
competitive. You need to get technology to a point where m- making that switch is not a lot of heartburn
No.
for the builder.
And well, probably the variety of load in a dwelling will require more time, okay, to be the mass. But it's also a good illustration of the difference between an AC system and a DC system and what power management means. When you have the old mixer with a cord on the AC
Yeah,
plug, you have a 500 watts system in your hand, and you use 500 watts for a few seconds each time you press on the
right,
button.
right.
When you have this USB system, the impact on on the plug is a few watts to recharge a battery,
That's right.
and it recharge for 12, 18 hours
Yeah.
for the few seconds you use. And that's exactly why DC manage the power.
Yeah. That makes a lot of sense. And I love that illustration because, like, to your point, that conductor, that USB cord, it's plugging into USB. There's not a lot. It's not a lot of power that I'm pulling out of that. It's limited.
It's
That's
very
a,
limited.
it's right. That's they made by definition, right? It's a power limited power supply. So I am powering the battery, and it's getting most of its power from that battery to
Mhm.
turn and do its job, but I'm not impacting the power distribution system.
Exactly.
And then I can control
Yeah.
the charging of that battery
Mhm.
based upon the voltages and whatnot in the
Exactly.
system. I
Ex-
I I like that because now I even I sit on code panel two as part of the National Electrical Code, and we're talking about a, panel two handles Article 210, which is brain circuits, and brain circuits they connect to loads. So we get a lot of interaction with cord and plug connected appliances and things like that. So now where we're talking is we're starting to see manufacturers of appliances like stoves
Mhm.
that have built-in batteries, and they're doing that, right? So they're running that stove off of that battery, and they're one of the messages they had was that, in a power outage, you're still going to be able to use your stove, and you'll be able to use these other, like to your point, of these other appliances because you've got that distributed energy storage, smaller batteries, et cetera, just like your computer. We lost power the other day, or just in one of the meetings, and we were all, on our battery powered computers.
Yep.
So they're doing that in stoves, and then they talked about the stove being able to power other equipment.
Okay.
So we're getting into the debates and discussions about reverse power flow through things like ground fault circuit interrupters.
Exactly.
And so you have the reverse power flow through GFCIs and AFCIs, and now that's a concern. So now the product standards have to change, but that's an AC world. That's not a DC world.
Mhm.
Right? So in DC, I've got to think about things differently. Do I have GFCI protection? Do I have shock protection? It doesn't, I think there's some gaps or are there's like our CDs,
Yeah, we
right?
do.
There's opportunities there.
Well, we can do. As long as you have an electronic device,
Yeah.
semiconductor system, the extra cost to implement residual current protection or everything inside is very,
Yeah.
very small.
I always say it's just software.
Yeah. Uh,
And my engineers go,
yeah.
no,
Well,
right? It's not just software, but no, but yeah, but to your point, because all of those devices are smarter, and a lot of like the USB technology is power limited.
mm,
I don't need to have a GFCI that's powering that USB,
mhm.
and then the appliances that are implementing the energy storage and utilizing that, the product standards with double insulation and things like that protect the user of that
Sure.
appliance
Absolutely.
from the power that's in that battery and the discharge
Absolutely.
of it. So it's a different. I think Antonella said it, and you said it. It's a different solution
Mhm.
to solve the problem,
Exactly.
and you've got to think differently.
Absolutely. Absolutely.
I'm getting it, and I hope everybody out there is getting it too,
Hope so.
because yeah, that's a part of our journey.
And if not, we are ready in currentOS to welcome you and to help you, to support you.
Absolutely right.
Well, we are an open ecosystem.
Yeah.
There is no barrier to come to join.
Mhm.
Well, there is obviously an agreement, which is mainly an IP policy in order
Sure.
to avoid someone to prevent us to continue.
Yeah.
Okay?
Yeah.
Something like this.
Yeah.
But it's open. So any company is interested in this will be welcome.
Excellent. And they can go to the website if somebody wants to join.
Absolutely. currentos.org.
currentOS.org. I'll put the link in the description or
Yeah.
somewhere on the video. Maybe I'll do a QR code. I don't know.
Hmm.
But yeah. So even if they're interested and they want to learn more, they can reach out to currentOS, and we'll be more
We
than
have
happy.
a LinkedIn page. We
LinkedIn.
publish a lot of news. Okay.
Excellent.
And we even have a YouTube channel. Maybe you
Oh,
could provide a few links on some of the videos that are
absolutely.
pretty technical tutorials, but
Yeah. Yeah. Yeah.
can also help to go deeper.
Yeah, in these discussions, and somebody asked me if I carry all this stuff with me, and I do, and sometimes I use it, a lot of times I don't. But a lot of people would not travel to Lisbon to
Hmm.
be here, even if they were members of
Hmm.
currentOS. And I go to a lot of these types of meetings, whether it be in other countries or it be even in the United States. I'll go to like the correlating committee meeting, or I'll go to code making panel meetings, technical meetings, and I try to capture even my own thoughts or others, like what we're doing here, because it gives some exposure to those who might say, I'm not going to go, but now I see what I'm missing.
Mhm.
And maybe it's worth my time
Mhm.
because they'll meet people like you and Antonello and others who are all like-minded. Like I go to IEI meetings, or I go to the NFPA code making panel meetings, you're with individuals who are like-minded. Everybody here believes in DC distribution.
Absolutely.
And if you're even not even sure if you believe in DC distribution, and by coming here, listening of the projects they went over yesterday and today, all the example projects and the solutions, the one gentleman talked about those battery, and he had the office desks where you plug that battery system in, and he built the whole system, and you just USB, and you don't have to worry about whether or not you have a receptacle in the floor and everybody's running cords to plug in. It's a great solution, and it's DC powered, and you learn about all of those things, so trying to share that is an important piece.
And newcomers are always surprised by the passion and the dynamic of this community. And frankly, it's sometimes also a bit different from a lot of electrical gathering, where electrical engineers come together. It's very serious. And
Oh,
sometimes
yeah,
a bit sad. Here, I can tell you, DC is fun.
absolutely.
And we consider this as a crazy advantage of DC, but it's real.
It is real, absolutely. And they, like you say, there's a lot of passion behind just the individuals who are presenting their projects. You could tell they are all in. And because it's such a new world, if you've lived in the AC world and you're interested in electricity, to start down that road of DC, to understand all of the things, it's like learning something completely. It's like learning a new language and you just want to speak it, because you want to practice it. And then as you're designing and developing, putting things together, and you come back to a community, because you asked a good question. I think it was you that asked, or maybe it was Antonello that asked, the one gentleman, what were your problems that you had to overcome in your project?
Exactly.
And he shared those because we're all learning from each other.
Absolutely.
Everything we do is new, and we're all going to grow together. And then you realize, I'm not I'm not the dumbest one in the room. We're all pretty dumb when it comes to learning something very new, and we're all learning together, and then the fear goes away of sharing information. We're asking those questions.
Absolutely.
Yeah, I really enjoy the the group sessions and all that. So it's a great opportunity. So anybody who wants to learn anything about DC, if you ever want to get interested in DC, currentOS is the place to do it. The greatest minds in the world in DC are a part of this organization, and there is much to be learned. And what I love about it is there's no stupid question. You can ask the question, and they will take the time to answer it, even though you think, man, I don't know if I want to ask this. You ask the question, and they turn, pivot, help you understand it, and then they move on regardless of where they're at. So it's a great organization to be involved with.
Thank you.
So thank you for what you do. Because I know it's a lot of time. I mentioned it to Antonello, and a lot of people in Codes and Standards know it, but a lot of people don't understand the fact that, yeah, we get paid to be an employee of our companies, but I don't know too many people who would work on the weekends, work in the evenings, right? Voluntarily and passionately.
Absolutely.
My wife can't understand sometimes, she's like, you're leaving on Sunday. Yeah, I'm leaving on Sunday. I've got a class I'm teaching on Saturday, and it's a hobby, it's a passion,
Yeah.
and it's a commitment that we all make personally. And we make a lot of sacrifices that a lot of people don't know about. So I appreciate your leadership and where you're taking currentOS
Thank you.
and all that you do for the industry. So I really appreciate it. And I know everybody out there does.
Yes.
Yeah. Cool. Yannick, we've probably come to an end.
Thank you.
We probably talked for 4 hours.
I love this conversation.
It was good.
We can continue. We can have another chapter.
We have to do it. Where are we going to be next? We're going to be in
Aachen, Germany.
Athens, Germany.
Yeah,
So
in end of May.
end of May.
29.
Yeah. I'll have to convince Rogalski and Luis.
And we will be in probably in the USA. Well, maybe Chicago, maybe California. It's not exactly this
I know.
yet.
Yeah.
In October.
Oh, in October. So if you were watching this and you're in the US, October, you'll have an opportunity
Yeah, absolutely.
to participate. And then if you are in anywhere in the globe, we can always, we'd love to have you. Would have been great to see you in Lisbon. but could be in Athens. Is it Athens or Aachen?
Aachen.
Aachen.
Well, it's CH.
Oh, it's okay.
ACH, but Germans say Aachen.
Aachen. Okay, Aachen. And he showed the map of where it was in Germany. So
Yeah,
if you're anywhere near Germany, and we have had a lot of people from a lot of different countries here today.
absolutely.
So
Absolutely.
it was awesome. Awesome. All right. Thank you.
Very good. You're very
Thank
welcome,
you for
sir.
your time.
It was great.
Appreciate it.
Thank you. Bye bye, everyone.
Take care. Stay safe and please stay healthy. Always say that. All right. So that worked out good.